With that, we can now talk about finding horizontal and slant asymptotes, which are much more difficult than finding vertical asymptotes. It's not as simple as just taking our factor from the denominator and setting it equal to 0. There is a process here. So to find the horizontal asymptote, we say that if the degree of the numerator is less than the degree of the denominator, then y equals 0 is the horizontal asymptote. So if the largest exponent of your numerator is 2 and the largest exponent of the denominator is 5, then automatically you know y equals 0 is the horizontal asymptote. There's nothing to do. Very easy step, just requires you to memorize this formula, this method. From there, if the degrees are equal, then we divide the leading coefficients. Really, you can just divide the lead terms, but all you need are the lead coefficients, if you can remember that. So just divide the lead coefficients and set that value equal to y, and that is the horizontal asymptote. So if the largest term, meaning the largest exponent in the numerator, is 5x cubed, and the largest exponent in the denominator has a term of 2x cubed, then you would just set y equal to that 5 over 2. You can ignore the x cubes, or you can let them tag along as well. They'll simplify out anyway, but y equals 5 over 2 would be your horizontal asymptote. From there, if the degree of the numerator is greater than the degree of the denominator by 1, and only 1, then there does not exist a horizontal asymptote. So remember, this backwards capital E with a line through it means there does not exist. The backwards capital E without a line through it means there exists. So if the degree of the numerator is greater than the degree of the denominator by exactly 1, it's not a horizontal asymptote, it's a slant asymptote, meaning it's a diagonal asymptote, like that. And we find that by dividing the polynomials and setting y equal to the result, ignoring the remainder. You can do this with long division or synthetic division, but if you have the choice, I suggest synthetic division. It works a lot faster. So, for this first one, we want to find the horizontal or slant asymptote given f of x equals negative 10x plus 6x cubed divided by 2x cubed plus 5x squared. So we look at the degree of the numerator and denominator. Notice they are both 3. The largest exponent is 3. So our formula says if the degrees are equal, set y equal to the lead coefficient of the numerator, which is 6, a positive 6, over the lead coefficient of the denominator, which is 2, again a positive 2. So y equals 3 is the horizontal asymptote, since the degrees are equal. And this is all the work that we would need to show for a problem like this. Just make sure you show y equals the division of the two lead coefficients, and then maybe make a quick note to show that this is why you're doing it, because the degrees are equal. From there, our next example is to find the horizontal or slant asymptote and vertical asymptotes given f of x equals x squared minus 4x plus 1 all over x plus 2. Okay, so to start off with, we can't factor this. X squared minus 4x plus 1 does not factor. So in terms of vertical asymptotes, x plus 2 is the only factor in the denominator, and since it can't cancel out with a factor in the numerator, it is a vertical asymptote. So we'll set x plus 2 equal to 0 and solve, subtracting 2 from each side. We get x equals negative 2, which is our vertical asymptote. And now that we've quickly gotten that one out of the way, we can focus on the horizontal or slant asymptote. And notice in this case, the degree of the numerator is 2, the degree of the denominator is 1, so the degree of the numerator is greater than the degree of the denominator by exactly 1. That means this has a slant asymptote, which we find by dividing. So we'll go ahead and use synthetic division here. For synthetic division, which only works if you have a denominator like this, x plus or minus some number, you take this value and set it equal to 0 and solve for x, which we've already done to get x equals negative 2. That's our value on the outside. Now we take all of our coefficients, so 1, negative 4, 1. And always remember to check if any x's are missing. So if this were like x cubed and this were x squared would be missing. So we would fill in a 0 for that missing x squared. But in this case there isn't, so we just want 1, negative 4, 1. And now we bring down the first value, 1. We multiply by negative 2 to get negative 2. We add the results. Negative 4 minus 2 is negative 6. Negative 2 times negative 6 is 12. Plus 1 is 13. And now 13 is the remainder, which we don't care about. We ignore it. This is all we need, the 1 and the negative 6. So since our numerator was x squared, we start with x. So y equals 1x, or x, minus 6 is the slant asymptote. And we've now found all of the vertical and horizontal, or slant in this case, asymptotes.